I have to walk when I talk because I'm just a pacer anyway, and it'll allow me a chance to see the slides that we're working on from today. This is me. I'm an independent. I work in oil and gas exploration, and I work also on a lot of things related to new technology. Our talk today is Resources for Independence, and I'd like to, first of all, this is the Society of Independent Professional Earth Scientists. This is our February technical luncheon meeting. We're fortunate to have the Society of Professional Evaluation Engineers with us today. Welcome, everybody. It's nice to see a big crowd. I hope you all enjoyed the talk today, which is about Resources for Independence. We're going to be talking about free data and software, though in truth, you paid for that free data and software with your tax dollars. So I want to start off by saying welcome, bienvenue, all right? Bienvenue and welcome, because you are now part of the singularity, of the technological revolution, of the new renaissance that's been occurring, okay? All of us in this room have lived long enough to see what is essentially a radical change in everything we're going to be doing over the next few years. The rate of change is increasing, not slowing down or stabilizing out. Every day you're going to see new physics, new material science, new biology, new computing, new programming. The rate of change is so phenomenal that it is a singularity. All right? Now, we can take advantage of some of these things. We can bring ourselves together. We can work together in focus groups. We can decide that we can recycle our planet. We're going to have so much power that the independents and the individuals are going to get so much from this that it's just not even hardly within our imaginary grasp. Now, I've got this stuff on a timer to make me go fast, so I'm going to say caveat emptor real quick. Watch what you're buying, because you're paying for free data, you're going to need to do some data management. Be careful. All right, we're going to talk about data and resources, mostly the data, not the software, but the data is the important part. Let's start granular. Let's go with well data. That's something everybody here in the room probably wants to see. You need, when you're looking for this stuff, logs and locations and status and any number of things. Well, so I'll say, Igor, what do we have in the way of log data?
Oh, master, we have all kinds of log data. We have geophysical logs, and we have samples and cuttings and bin sections, and we can see all these in a GIS.
Oh, that's wonderful, Igor. Thank you. Igor, by BEG, provides us this data quickly, easily, through a GIS system. You can go into the GIS system from the front screen that BEG offers. You'll get a query screen below this one, in which you just get to enter the criteria that you're interested in. All right, and you'll be able to get a list on your map in the area you're looking at of the wells that have the characteristics you've requested. So this particular data set will give you a lot of geophysical data, both logs and samples and cuttings and that sort of thing. But it's not necessarily complete, and that's one of the big issues with your government data, completeness. So here's a list of some places you can go to get the physical data. Austin, Midland, and Houston have about 2,000 boxes of core data, and you can find other data in some of the universities and with the USGS. Another major source of data for you is the Railroad Commission. Now the RRC has the main page here, and they offer a query screen that lets you go and enter data in textual form so that you can say, oh, well, I want to find this well in this field and whatever, and it'll pull up lists. But they also have a GIS. So you can take the GIS and you can do the layer tools and you can zoom in to the areas that you're interested in, and you can pull up the well data or whatever data you're interested in that particular area, okay? There's lease data in there, there's survey data. You can even tell it, oh, gee, I want to see those wells that have geophysical logs. And you can highlight them in yellow and say, oh, gee, these are all the wells in the area I'm looking in that have geophysical logs that I can see. Okay, and I can request that log data. Now that log data is going to come to you in an image format, right? It's not going to be a digital log, but it will be an image of a log that you're interested in seeing. Now, I wasn't going to bring up production because we don't have a lot of graphical production tools, but the production data query tool, PDQ, from the Railroad Commission does allow you to get in and look at all the production-related data and cut and paste it into a spreadsheet, which will be useful to you. These are just slides in the deck. You can get to the slide deck. Linda's planning on putting it out for us. And you'll be able to see kind of extra entries to show you where things are and URLs you might be interested in. Now, if you look at Louisiana data, they have a very similar situation. You go to the Department of Natural Resources website, located here. You can see from there that they have a lot of choices. One of them is a GIS. If you select the GIS, you're going to see Louisiana. You can zoom into a particular area. It's the same in some ways. It's not the same GIS, but it's similar. You can pick your layering. You can say, I want to see the wells. You can then zoom in. You can select particular items in the map that you're looking at to get additional information about it. So if you go in and you zoom in, you can select the well. It'll give you some information about that well. You can then drill further down and you might say, oh, gee, show me the log data. And so you can get a pull-up of the log data, which is induction, sonic, SP, gamma, whatever's available in that well through the Department of Natural Resources in Louisiana. They'll show you, and you can download that data from here. Again, that's an image. You can also see additional data in the Sonorous system because you can look up production, cumulative preparations, any number of things about the data. And like I said, again, you can get the image of the log data curve itself. Now, the Louisiana data is, this is a list of some of the things about Louisiana data. This will be useful to you if you look up the slide deck later. There's a contact there at LSU and at the Department of Natural Resources to help you out. A lot of the same situation as we had in Texas as far as looking at the data. Let's talk a little bit about geological data and open source data now. One of those data sets is Data.gov. And Data.gov is this website. If you go to it, you'll see on the bottom a whole bunch of topics. You can pick a particular topic and start drilling down from there. But you can also just type in something that interests you, like, gee, Montgomery County, Texas. And you can then request information about it. It'll show you almost 1,000 potential data entries and crosses of Montgomery County in the database. So you say, oh, well, maybe I'll just look at geology in Montgomery County. So it'll trim it down for you. Maybe you'll only end up with 300 or 400 data sets. It's still a lot of data, but they do a really nice thing on this website. Along the left side, they've organized how many of our articles and data types you got in there. They'll organize them by type on the left. So, oh, well, I've got so many geochemistry entries, and so many GIS entries, and so many well type entries. So this is a very good data set for pulling up something like that. If you wanted something more dramatic, more intensely focused on your area, like in my case, geophysics, I could have added geophysics as a criteria. I saw there were 71 listings. The top one was the magnetic data, aerial magnetic data. And you can pull up a query about that, go right to it from the map. It'll show you everything about that acquisition and allow you to download the data. And that's a key thing, I think, in a lot of what we're doing here. Another choice is going to be the National Oceanic and Atmospheric Society. They have administration. They have quite a bit of data. A lot of it's observational data, climate data. I don't use this site much. Some of you or your kids might want to use this site. They've got a good Landsat viewer. Okay, you can pull up things that relate to flooding and all kinds of things that are more surficial or atmospheric. It's the atmospheric site. And you can zoom in down to Montgomery County if you wanted to and see a very detailed Landsat. Now, most of these GISs we're talking about will give you access to that Landsat data. Some of them will give you access to more kinds of satellite data than others. Okay? So anyway, you can use this tool to come in and out and look and see, do what you want. You can export some data out of here if you need it or capture it and somewhere else. My favorite site is probably the USGS. Now, the USGS gives us a central site that's kind of tab-oriented. When you first open this thing up, all these green things are going to be open because they're just tabs. Mineral resources, geochemistry, geophysics. Across the top, you see the GIS maps that they'll let you access. Those are great resources. I pulled up one of them, which was just the one with the state geology on it, just as an example. We'll go a little further into detail on the next one, which is, again, a GIS. Most of y'all are old enough, like me, to remember how you used to have to do it. When you go into a new area and you didn't know something, right? You'd start researching at the library. You'd spend a couple of weeks looking up papers, looking up cross-sections, looking up maps, figuring out what was going on. Now you can come into this site. You can come drill down to, or zoom into an area where you have some interest. You can say, oh, well, you gee, all these streets and maps of streets and cities. I don't need that. I'm looking at geology. You just turn it off. You go through the listing of layers that you've got in here, and you can turn on the state map, the geological maps for all the states, and see them there. You can turn on the magnetics. You can turn on the gravity. Okay? And so this website gives you access to a great deal of this regional data that we've always used to firm up our exploration production ideas. It has a lot of features in it that are really nice. In particular, I like the opacity curves in this one, because each one of those data sets that you select allows you to control the opacity of that layer, which means while you're still playing in here just kind of reconnaissance, looking at the data, you can merge all those data sets, highlight them in different ways to accentuate certain things that you're interested in. And that data is shareable for you. You can pull it out and put it somewhere else. Let's see if I've got the timing. Well, I'm a little faster than I'm saying because I'm still looking at this current map, but we'll move from here to this same map, but look at it a different way. The US Min map, which is the minerals map on surface, this is an excellent map that you also get from the USGS. All these URLs are on top of these slides. You can see the slide deck, so you can refer to all this stuff later. The nice thing about this one is it gives you a layer access again to all the different kinds of data that the USGS would like to provide you. One of those is a state geology map, the one we looked at a minute ago. Now the interesting thing about this version of the map though is I get to directly query it. Y'all remember when we did this stuff in libraries and at school and we were studying before in hard copy, you'd look at the map and then you'd go over the legend and you'd say, oh, well, that beige kind of looks like this beige and, you know, that's probably this rock. And it'd tell you what it was. Well, now you can go in here, point to the map in the area you're interested in, and it will tell you the geology of that rock surface outcropping there, those surface minerals. It'll list them where they are. It'll give you the geochronological age. It will show you what kind of rock it is. It'll let you separate out the features. So if that outcrop is actually in two places on either side of the stream, it'll let you select it and then tell you what's in that unit on the surface, what kind of rocks are there. Obviously, this kind of stuff is great for surface mineral mapping and surface exploration. Okay, a lot of times we're dealing with stuff a lot deeper, but there's a lot of shallow opportunity, and people still do look for gold and silver and all kinds of interesting things, and they can use maps like this. Another nice feature of this particular map is it has a great curtain on it. Okay, and in this particular case, I selected one. You've got a line down the center here, or on one edge. Okay, and what it does is it lets you go back into that same layering of the maps, select whatever maps you want to see. You can put one on one side, you can put one on the other, all right? Then you can kind of slide this curtain back and forth, all right, to help you visualize the kinds of things you're trying to see in the data. I believe this is moving forward. Yeah, I was fumbling with it a little bit because I'm actually new to this. One of the things that's been exciting about this is how fast your data access changes. There's more stuff there all the time. All right, data that didn't make it, that's on in the route or in the pipeline somewhere, it comes here. And so you can come in here and find all kinds of tools to help you reconnaissance the data. Another good tool they have is the National Map Viewer. I tend to use this one for drainage. Okay, you can get hydrology and elevations out of this. It's like I said, it's a great drainage tool. I'll zoom into an area and look at some of that. Another thing USGS does is in association with state geologists. They offer these maps that are all the local publications and maps from the state geologists. You can zoom in there. You can do a query also on a GIS kind of interface. Say, show me what kind of publications are available from state geologists in this area, and you'll end up with a nice list of all that stuff. And it tells you even the scale of those things, which is very handy a lot of times when you're dealing with regional data to know what the scales are going to be. You also go to other sites of data for the USGS, and a good one is kind of a Google Earth equivalent, the Earth Explorer. And that's a nice map because it lets you get to all the satellite data in a kind of a world view. Now, I haven't mentioned seismic data yet, and of course that's an essential part a lot of times of exploration, especially for a geophysicist. You're not going to find any 2D data out there, not in the US, and you very fine little 2D in the world. You find 2 3D surveys. And the reason is because in the U.S. we license this data and it has value over a long period of time. You may never go back and shoot that line through that sea, right? So these things are good to know, but you can get seismic data offshore. The Bureau of Ocean Energy Management, BOEM, has a walrus, which is a great GIS, and all the pink on this map is 2D and 3D seismic that's available for our access. Okay? And by access, I mean you can go to that data and see what it is, and you can download it. So if I zoom into the Gulf of Mexico, I see a huge bunch of 2D and 3D data, and I can select one of those surveys. All right? And once I've selected that survey, it'll zoom into it for me, and it'll tell me all these things about it. I'll know that it was shot with an air gun by streamer. I'll know what the parameters are. I'll be able to download the data. So here's some links from BOEM with some good data sets on them. So that's a good reference slide as part of the slide deck to just help you find BOEM data. There's also a bunch of hidden slides I'm not going to cover today that in the BOEM, but you'll be able to see them in the slide deck. But they weren't graphical enough. Now the Cadastre survey, this is really good for offshore, especially bathymetry data. If you're interested in this kind of thing, you can go and you can see where the maritime shipping lanes are, you can see where fishing regions are, and things like that. We have a few minutes left, so I'm still going to talk about another resource, which is software. And probably principal among your software uses that is free is going to be Google Earth. This is a tremendously valuable resource to you because it allows you to take all that data we've been talking about, you download it through a GeoTIFF or a JSON or some format, and you can put it in a KML file and share it with your customers in Google Earth. You can also go over here to this Wiki site, okay, for free geophysical software. That's a big list of all the different kinds of software you can access that will allow you to do various things with the data, but it won't cover everything. And among the things it won't cover, or the problem that you've got with a lot of paper prints and things, is the fact that you're going to want to go to A to D. You're going to go from analog to digital. So you're going to need some tools to help you do that. But they can be found. I'm going a little fast, but there's a little free slide there that was talking about good stuff. There was some conversion software from Golden and Zamzar to help you convert formats. There was in the new Windows 10, there's a free movie recorder with audio overprint. Okay, that link shows in there too. Your Windows 10 actually has that, so you can make your own movies off the browser. I was going to take a few minutes to try to talk about a more complex subject than this, just to give you a sense of it and have it in the slide deck. And that's this issue of open source versus closed source. Okay, basically we've got three kinds of things going on here. One is open source where they'll give you the code. One is a shareware where you don't get the code, but you get limited use on the software. And one's a freeware where you just get to use the software. Skype, Google Maps. You might see Autodesk and Fusion, Photoshop, and things like that up in the limited use area. And what they'll do is that, maybe they won't let you handle files over a certain size, or you may not be able to go to print, or something like that, but they'll let you freely use the software. So there's different categories of software and data, and this really in many ways this applies to data too. There are different categories of that stuff out there for you to use. Okay, am I getting close to the end of this now? Yep. Gonna wrap it up for you anytime. The profitability on these two, mostly you're getting added value products sold in open source. Actually, you're buying something for the free period usually, or seeing ads in the freeware and shareware. This is actually just a textual description of what I was talking about with the silos in the picture before that, so you can just use this as a reference to try to explain what's going on. Here's some more extras that are interesting. The HGS, Susan Nash, John Tom from our society, and somebody else wrote an article. There are lots of URL links in the data, Oklahoma, all kinds of places where you want data. The format conversions by Golden and Zamzar, those are free. I used them in this case to change from some MP4 to some MPEGs to run the little movies. Here's that Windows link for that free capture of video. And that's it. I hope that went fast enough. We left a couple minutes for questions. If anybody has some, I'll be happy to try to answer them. This is a pretty deep field in terms of things that are available, so I won't have answers to everything. What can I do for you?
Pretty straightforward one. I know it's going to be broad variety of answers from this, but let's use Texas Federal Commission example of Texas data. Historically, how far back does it go? Generate it now, but obviously there's a limit on how far back.
Well, okay, I tried to include this. Yes, he's concerned, Craig is concerned about the age of the provenance of the data. Not just the provenance of the data, but the provenance of the data in terms of age. When is it out there? If it's old enough, is it in this data? And the answer to that is no. All right, and you'll notice if you go back and look at this slide deck from Louisiana, I've actually got you a name and a contact person who you would call and say, oh, I want this log, and he might go scan it for you for 15 bucks, okay? And then you put it online and it would become part of the system. Because the stuff's there's not enough resources to do all this, so it's happening kind of on a case-by-case basis. Is also true with a lot of our Texas data. If you show an interest in somebody and you get one of the guys that's there to do it, they'll put it online and it'll become part of the system. Otherwise, it's not there. And that's why there's the danger of this free data is often its completeness. Okay? When you're looking at this data, I think you can largely rely on the data itself to be of good quality. But for any given place you look, there's a good chance that that's not all the data in the area you're looking for. So you should be cautious and be aware of the number of things that are available. Like I said, I gave you a couple links here and in Texas to try to chase that old data. Earlier than 85, I think, was the stuff that you have to pretty much ask for. And you're not, it's probably going to be a long time before you see core photos and thin sections and things like that online. You'll end up having to go look at the cores and sample data in the facilities. Anybody else? Yes, Linda?
Now, for seismic interpretation, don't you use software or IP in some way?
Yes, okay. I didn't have enough time really to do, once I started putting this together, I had so many data slides that I couldn't really talk about software very much. But yes, you have a number of options for interpreting and analyzing seismic data. I'm very partial to OpenTech as a seismic 3D visualization interpretation system. It can also be, it's also free at that level. You pay a little bit more for it as you go because it's even though it's open source, it's got add-ons that are valuable. There are others like this, Resolve Geophysical. They sell you a data package with a bunch of attributes, but then you can use their software for free, which is excellent data analysis software if you're into attributes. So there's quite a few things that are available, okay? I can't really cover them all. Those of you that are geophysicists probably know some of them, like SciC, where you can actually pull up data and look at it. But there's lots of resources for you, and there's even quite a few free resources for you. Large cross-sections seem to be a bit difficult with the free systems right now, but like I said, you can even interpret fairly good-sized 3Ds. Anybody else? Yes, sir. The slide deck will be on the site page. Linda's going to take care of this. By the way, let's have a hand for Linda. Great job doing the technical chair last year, and then she's also volunteered to take care of this education stuff for sites this year. And please do attend the sites workshop next month. The talk that day is going to be, it's really very in line with that meeting. It's about shallow Biloxi oil sands. Okay, Scott Coates going to come and give that talk next month, and then I will go to the CES lecture. And but you should be able to see this entire slide deck online. I think she's even videoing it for posterity, so maybe we can see that on YouTube or something. Yes, sir. Henry. Yes, I do. That's a good question, but I wasn't putting Canada in my list. You were saying Canada has a lot of good free stuff, and they do, okay? But we weren't really going to talk about Canada. But it comes talking most of the time. I didn't get up into Oklahoma or Arkansas because it was hard enough to cover Texas and Louisiana, okay? There's just a wealth of resources out there, okay? If you wanted something specific, you can sit down and talk about it, but I think it's probably a little bit much for this. Anybody else? Something simple? I can answer easy questions. Yes, sir. What can I do for you?
Steve, we know from the place we used to work, some of the in-house databases that do bring thin sections, more pictures, everything into that. With all the mergers and whatever, companies essentially providing some of that for the government to maintain or whatever. There's some of the in-house stuff is really nice.
Yes, and again, I think you're talking about resources at the university or EEG level, and they're limited, okay? We'll take all this core data. All this core data came from Africa, right? I mean, or great big chunks of it came when they unloaded their library. So as these companies have merged and gone out, they have had a lot of this. You've got a couple of issues. One is seismic data, because licenses never let you transfer the seismic data, all right? So the other data, which is mostly going to be cores or cuttings or samples or thin section pictures, we really don't have a system, right, to display it. So they've been working on that. I talked to a couple of those guys, and they had a big inventory project going, okay? But a whole lot of the core data is not even inventory, okay? So when I say this stuff is not complete, it is not complete. You might really want to go to the facility itself and start looking if you want something. Right? Because it's just not online. And yeah, I think we'll get there, and at the rate things are going, I wouldn't be surprised if it was in a couple of 3 years. But we're cutting back on the expenses, right? And we're cutting back on the dollars the USGS gets. So all of this stuff that we're seeing, it was generated over the last decade because money was going into this for Freedom of Information Act and access to government stuff. So, you know, we drove this. Anybody else? Thank you.
Thank you, Steve. I think we have a presentation from SPEE for you.
Oh, well, thank you.
On behalf of the SPEE, I just want to give you a small token of appreciation.
Well, thank you very much. Well, I appreciate it, and I hope this was interesting to evaluate with engineers.
So, thank you.
I'm sure Steve will hang around for a little while. If you have any questions, come up and he'll be glad to answer them. Thank you for coming. See you next year.
Thank you, everybody.